form to solve for a. And the way to do that is to write it as p is equal to a divided by 1 plus I to the power of n. That's it. You're just going to take this and bring it over to the other side. It's just going to be the denominator. So now that we have our equation, is 10,000 all over 1.0065 to the power of 36. All right, let's do that. So 1.0065 exponent 36. That is just one really long decimal. I'll write it out for you, but normally I just do this in my calculator because I know how to use my calculator. But if you don't, go back old school and write everything out and show your work, show your steps to get full marks. So 10,000 divided by that giant decimal there. Answer is 7,919.61 cents. So what does this mean? That means right now I need to invest $7,919.61. And in 3 years, because of interest, that will turn into $10,000. That's what the question was asking. And once again, I expect the answer to be different or same. Let's see. Than the other one here. 7919.6. Oh, okay. 1 cent is not a big deal. That's 1 cent is within an allowable answer. And the reason why is because they kept, see this 0.0065? 0.065, we kept the same R value. We didn't round in this case. So yeah. In solving for unknown variables in compound interest problems, online calculators can be very valuable and time-saving tools. They can be used to calculate amount, future value, and the principal, and the total time or the annual rate. Here we have, once again, compound interest. What is the interest rate per annum that is required for 2,500 to grow to 3,500 in 8 years if the interest is compounded quarterly? Oh, this is getting hard now. You thought the first two examples were hard? No. This one and I think the next one are so much more difficult. Here they're asking what is the interest rate per annum that is required for 2,500 to grow to 3,500 in 8 years if the interest is compounded quarterly. So what are they asking here? This is the tricky part. The formula is this. That's the formula. A is equal to P times, brackets 1 plus I to the exponent n. So we have 2,500 and it's going to 3,500. So right away, 25 is the initial amount. The future amount is 3,500. We got 8 years, which is your time, which can be n, except you have to calculate it. So n is equal to 4, because quarterly, 4 times 8, which is 32. What about I? Do we have I? The answer is no. That's what we're solving for. What is the interest? That's what we're looking for. So let's plug it in, plug all the numbers, and see if we can figure it out. 3,500 here. 2,500 here. 1 plus I. And then exponent is 32. because compounded quarterly, that's 4 times a year, and then it's 8 years. So let's divide both sides right now by 2,500. That's how you solve this. Cross, cross. 3,500 divided by 2,500. Just use your calculator. Get 1.4. 1.4 is equal to 1 plus I to the exponent 32. Guess what? If you don't remember, if you have something like this and it's like squared, you take the square root of both sides. In this case, it's not to the power of 2, it's to the power of 32. You can take 32 roots of both sides. And if you don't know how to use that in your calculator, there is a symbol that looks like this, at least in my calculator, where it's an x square root y. And if you press that button, your x value is supposed to be 32 in this example, and then your y value is 1.4. It's very doable using a calculator. It's a very simple calculation. Just make sure you know what you're doing. You should get 1.0105. Oops, I'm going to keep all the decimal places. 7, 0, 232, yeah. 232 equals 1 plus I. Bring the 1 over. You're going to subtract 1 from both sides. And if you minus 1, you obviously get the same number, except instead of the 1 in the front, you can have 0, 1, 0, 1, 0, 5, 7, 0, 2, 3, 2 equals I. But don't forget that I is a little bit tricky. You have to remember that there is a J value, and I is equal to your rate, interest rate, divided by J. Remember R over J. So interest rate is over J, and in this case it's compounded quarterly, which is 4. So the final step that you just have to remember to do is to multiply it by that compounding frequency. So this decimal that we got, just times it by 4. So your interest rate is equal to 0.042. And if you times it by 100, you can write it as a percent, which is what we prefer, 4.23%. That's the answer. So this is what the interest rate has to be for your investment to grow from 2,500 to 3,500. You have to have something that pays out 4.23%. And they have 4.29. Once again, this is a rounding error. Make sure you are not rounding and figuring this out. Here we have another example. How long does it take for 3,000 to grow to 4,500 at 7% per annum, compounded monthly? Very similar question as the previous one, except we're looking for how long. So A is equal to P times 1 plus I to the power of N. Remember, N is equal to your T in years times your j value and j